Hello, I'm going to talk about SWMM. It's really cool software and free. So every time before we create a project, you need if you want to draw it by hand, um, the two ways. One is you have all those watershed boundaries, um, you know lines, all those kind of things, and you import from GIS. The other thing is you just draw by hand. In this case, I'm draw by hand. What I do is you can easily, insert image down here like a backdrop. See here, backdrop. We can load and load, and you can resize them. You can give the dimension, how large is them, and you can trace them. Okay. Um, Usually the most important thing is you wanna see, you click the subcatchment and you click plus sign, and then you just draw. Okay, use the left button, and then when you finish you just click the right button, and then they will create a subcatchment for us. Okay, so that's how you draw lines in here. It's the catchment. Okay. um, so basically that's what you do. If you want to delete it, you just click the delete sign. And also every project have defaults, which means it's everything that's required for catchment and nodes. Usually there's only two kind of things. One's catchment, subcatchment, one is nodes and links. Okay. Which we'll talk about later. And ID labels is, you can add ID labels. See here, I'm sub, which means for subcatchment, every catchment I add, they will give a name start with sub. Okay, just some prefix you want to. And the rain gauges the same. Okay, junctions, we do a lot of junctions. Conduits, we do a lot of this also. So just understand that. And you want to delete it, just hit this minus sign, and you have them. But for every project, you see here, the default, which I talk about here. And this is for the subcatchments and nodes. All right. I want to talk about different parameters. For the rain gauges, it's basically you just click rain gauge and add object, and then just click, then it's gonna show up here. Okay. So this is like tell the computer how is the rain looks like. So once you have your rain gauge, you wanna just double click and you will set up the perimeter of it. Okay. So basically, most important perimeter is the rain format. You wanna use intensity, time interval. You can define what it was, but it all depends on the time series down here. Okay. So time series is the key. Rain units is, which means in time series, what's the units of it. So time series is from the time series here. Okay, so you will create time series in here. See here, I can add it, so you can add time series down here. So this is a time series I already added. So basically what it was, you give a name of it, and then they will show up in the time series you can choose, and you can even view the how the time series goes. This is a time series that is default for most of the people. You can create your own time series. And you just need to enter the name like this 00, so it's 5 minutes. See here, it's hours and minutes. Okay, so this is 5 minutes, 10 minutes, and this will tell you at that point what is the cumulative inches in terms of rainfall. Okay, basically that's what it was. So right now I just wanna remind you what this intensity means. For example, here intensity means each rainfall value is average rate inch per hour over the recording interval. Okay, so which means if you look at the series down here, so this means from 0 minutes to 5 minutes, right? This interval, the intensity is 0.3 inch per hour. Okay, which means the intensity of it. Okay, basically that's what that means. All right. Um, so typically, you go to this website. It's called Point Participation Frequency Estimates. You can get the state, the station's address, those kind of things, and they will tell you what's the. And I usually use annual maximum. Um, and what they do is they will tell you the maximum um, intensity inch per hour during every 2 year, 5 year, 1,000 year. Um, so you will know which is the peak condition. Okay. So in this case, you can see here the peak is this much. Okay. So you could basically estimate. So just make sure when you look at the number, if it's 5, 3.8, and then you could estimate every 5 minutes what's it gonna go. So use this one because it's kind of hard to get the time series data. Usually I just estimate, okay, because it's not totally accurate. Every range is different, so just make sure you do this. So it's there's some tricky things in here. Okay, it's how to enter the number. Okay, you could just enter the number based on the you know the proportion. For example, it's 538, which means the largest is 285. So maybe you just make the number all like 2 times large than this, because this is what happened naturally, right? And this kind of data is I don't know how to get them yet, so just learn this, but I know this website, which is very useful. Okay. Um, so this is about a time series. Once you have time series, you have rain gauge, you have weather data, which it makes sense for now. Um, so once this was down, and we should set up subcatchment. Okay, for subcatchment there are tons of information you need to enter. I just want to go through the slides here. See here, first is the area. We usually use GIS to generate this area, and second is width. This is really important. Basically what this was is it's calculated by using area, like this area, how many feet, and divide by their overland flow. Okay, which means overland flow usually means the length of the drainage line. So if the overland flow, in this case they flow like this, so that's the length of their overland flow. Okay, but there are issues with this is if the flow is larger than 500 feet, right? It's longer than 500 feet, you just use 500 feet. Okay, then you just use the area and divide it by 500 feet, because in natural condition, in natural areas, true overland flow only occur for distance for about 500 feet. Okay, make sure it's natural area. Okay, but if it's like urban area, it might differ. Okay, and also in this case, sometimes your drainage line is pretty complicated. Like here, you have 2 drainage lines basically. So what you do is just add all of them together, right? Add them together and divide by 2. Well, actually not. It's just multiply them by 2. Okay, because you have multiple ones, right? Basically, that's the reason. The same, but if you only have one, you just use 1. Okay. So, but this is another assumption of model that we're making. Okay, how to decide the overflow length. It's kind of another tricky thing. So, usually use as simple as you can. Okay, because we use GIS to calculate the catchment, and a lot of catchment they only have one line. It's okay, just draw estimate 1. So this is a better way of doing it. Okay. Well, slope, we use GIS to calculate the average slope of the whole area. That's usually what we do. And Manning's overland flow value. This is when you look at here, they have values. Basically, what it was is for different materials, they have different values. Okay, which means you should calculate if your catchment have 2 values, right? And you need calculate them based on the area proportion of it. Okay, the percentage of the area. If like 20% asphalt and 80% of concrete, then you use this multiply 20% and this multiply 80%. Okay, basically what that means. You have to weight sum them, add them up, and okay, so that's this, and then depression storage, which means there's a minimum volume before rain-off starts. Okay, typically is 0.05 for impervious, 0.3 for pervious. Just use this number. You should have big problem with it. And also percentage of impervious area without depression storage. It means some impervious area don't have depression storage. Like when the rain comes down, they just directly become runoff. Usually we use 25%. This is a pretty good number for that. And there are also infiltration model, which is you want to choose here. You can choose different models. Actually, it's in preset. You need to change it from preset, and you can enter numbers down here. Okay. The preset, as I talked about, is default and in the subcatchment, and you can find here Honton. You can choose different ones. Okay. Actually, it's only 3 green empty. There's one called modified. I usually just use the normal ones. Okay. And all those ones is just basically based on different soil something. You could actually show you here is you actually just let me see, it's somewhere here. So they're all different methods, right? And all these methods, they have different meanings. But basically it's based on the soil, what kind of soil you have. Okay, sand, clay, all that. Okay, let me see whether or not I have here. Okay, so see here, this is if it's soil, if it's sandy, loam, clay, how many inch per hour in terms of the infiltration. This is a green amped. So there's a soil character table, just tell you the infiltration, the conductivity, some numbers down. Okay, just based on different soil. Just understand that. You can figure them out. Just click the help file. But usually I use green amped. So the green amped, which is here, it's more fast and easier. So I usually use one. The initial deficit is the only one you need to do. Need your own input. Okay, which is see here, which is the fraction of soil volume that's initially dry. Okay, sometimes if you don't know what it was, just hit 0.25%. Okay, 25%. Just enter that. Usually have no big issue with that. Just rain gauge again. Just to make sure you have that, the rain gauge. Let me move this up to here. Okay, so make sure those are right. Okay, after you have a catchment set up, you need also the other one is outlet of catchment. So you need a junction in here. Okay, you need a node. Okay, there's all different kind of node. Just any kinds of node that is in here. Okay, it can be junctions, outfalls, other things. Okay, in this case, this is a really simple, the most basic hydrological model. Okay, it's just one catchment and the catchment flow to one outfall. Okay, and for the outfall, the only thing you need to enter, you can enter all other things. Okay, but the only thing that's required is elevation. Okay, just add an elevation down there, then everything is good. Okay, so once you have, everything is connected, you are ready to run. Okay, here is a button of run. You just click this run simulation, and they will give a report. If you have something wrong, they will let you know that you just usually is right. And usually the first thing you want to look at is summary. So just make sure whether or not it's successfully run. They will give you a summary about the catchment, basically based on what you have. Okay, if you have some like conducts or something, in this case we only have one catchment, so you will tell you what's the total precipitation, and evaporation we don't have that much, and infiltration we infill this much, and total runoff, how many runoff in terms of inch. Okay, and this peak runoff, which means how much you have in here. Okay, and runoff coefficient. Okay, you could also draw charts, which is time series plots. That's one I use a lot. Statistic plot, you can use that, but I don't really use it very much. It's just you can see here, tell you the mean, the maximum value, all that. You could try it. You could just play with them. You will see what happens. And plot value is you click something and then you can add. For example, I delete it. You click this catchment, you add, then they will add for you. Okay, and this is what the variables of here. For example, we can calculate runoff, or we can calculate infiltration or precipitation. Okay, in this case, I just click runoff, and you just click OK. They will create a chart for you. Okay, how many runoff it has. Okay, it's 0 before, and then you just stay here. And the unit of runoff is CFS. So again, the CFS just means cubic feet per second, which means 7 cubic feet per second for the whole site, which is not that much actually. You could just check, but it's not that much. And you could also by click the outfall, that's sometimes more clear, and then just create a plot, and just I think you can choose what I want to do. There's depths, there's volume. I think volume, total inflow. Let me see what depths looks like. They don't have much. Its depths also like this. Is there value? And then let's check the volume. Click OK. Note volume is always 0, because these are all default numbers anyway. So inflow, okay, total inflow, that's definitely different. So you can see here the total inflow is the same as the runoff, which is cubic feet. It's the same with the catchment runoff, okay, because all the catchment runoff, they go to this outfall, okay, which is an outlet, which means like all the water will go through this point. Okay, so this is a very, very basic thing. You could actually just change the rain gauge and change this 10 year, change to 100 year, and just run them again, and you could just check the outfall again, and this time I'm pretty sure it's gonna be different. See how much it was, right? Go to 30. Okay, so there's a lot of runoff generated. You could even you can also go to summary results and you're gonna see the coefficients. Okay, runoff coefficient is way more than before. Okay, it's 50%. Okay, so that's this for today. It's kind of a long, um, but just give a sense what this can do. Okay,